Okay guys, so now we've seen the experiment and we've seen these small ping pong balls rise. What I want to do now is go over the mechanics of what happened. So we have this original configuration with an unpacked, unorganized soil matrix, in between which we have void spaces that are filled with water. During the earthquake, so this is going to be before. During the earthquake, we have shaking. That shaking reorganizes this soil structure. As this soil structure is being reorganized, water is being pushed to the surface. The same way you take a sponge and push on it, the void spaces in it collapse. Right. Any water that's in those void spaces is forced to the surface. As these are being collapsed, the water is being injected to the surface and the soil particles are no longer in contact with each other. They're only in contact with water. So because they're only in contact with water, the only strength that this material has is the strength of water, the shear strength of water. That is why during liquefaction we have a material of sand that allows buoyant things to float and heavy things to sink. After liquefaction, we move over to the more consolidated soil matrix and see that we have a better organized soil matrix with much fewer void spaces present. Likely we're going to have some water that's on the surface here, but that's not really as necessary to know. What I really want you guys to know is the relationship between water, the surface, and the organization of the soil particles. In the next video, we're going to try and do another experiment with something heavy to see if we can get it to sink, just like we got this to float.